Right, good evening, everyone. Thanks for attending our third session here on Dispensing 301. And what we decided to do today was lens tolerances, thickness.
Wait, let me give you the date.
Yeah, you better give me the title again. I've already forgotten. Verification, tolerances, minimum blank size, and thickness of spectacle lenses. Now, this is something you people do every day in practice. Well, I'd like to think you do it, especially the verification. And tolerances is something to be discussed. And it's also maybe a bit of a debatable topic. Minimum blank size and thickness also. So before we get on to verification and things like that, let's see what happens in the practice from the minute you receive your pair of spectacles. Now, I'm sure this all happens in the practice, but just to clarify, let's hope it all happens. First of all, what you'll do is when you get the job back from the lab, now I'm assuming to start off with that you examine the patient, you write the order out, and you send it to the lab to fit. So when it comes back, which is my pointer here?
Yes.
Yeah.
Yes.
Okay. When it comes back from the lab, you're going to check the order number from the lab and make sure it matches the order. Obvious reasons. You don't want to mix your glasses up. You make sure that the spectacle frame matches the order number. Check that if the lens type ordered is correct. Pretty straightforward. No rocket science here. When I mean by check the lens type, make sure you ordered single vision, bifocals, PALs, etc., or whatever. Check that the correct tint is ordered, whether it's clear, photochromic, tints, filters, etc. Then you'll check for scratches, chips, stressness, grayness of the lenses. Basically what we are checking over here to make sure that the lenses are clear. There's no scratches. When I say chips, you might be thinking, how can plastic lenses chip? Easy. You know, if you normally prescribe a fairly high prescription, and sometimes you may find if the edges haven't been chamfered, it could leave sharp edges. Now, if your lenses are quite thick and the lenses stick out quite a bit and somehow it touches the patient's cheeks or whatever, it can do a bit of damage. So normally you just check to see that the edges are chamfered nicely and they're nice and smooth. Then, of course, we come to checking the prescription. Sphere-cell axis. Something I have left out over here, and that is the reading add if it's a bifocal or a progressive. You'll check the PD, Segart, pupil heights, prism, etc. Then, of course, you check the correct cost from the lab. Now, I don't know if you people do check the lab costings. I do it with every job that I receive. And you'll see now what I mean by that, because I'm going to make a point in this later on. Checking PD, Segars, pupils, and etc. Now, I'm going to ask a question. I know that you people can't answer direct, but I want to see what you people write in the chat box. Well, mind you, I'm going to ask a question right now. Oops, where are we?
That's just okay, perfect.
Okay. I want to ask a question. Everyone tuned in tonight, do you check your jobs? And be honest. When they come back from the lab, do you check everything I have just mentioned here? Now, there's a reason why I'm asking. So I've opened the chat box up here now. And I'm expecting everyone.
Yes.
I'm expecting everyone to say yes. And I hope you're all being honest. Now, obviously, I'm not going to elaborate on it, but
we verify the script in detail. Oh.
Okay. Yes. Right. Okay. I'm expecting everyone to say yes, but I can assure you now there are many people that don't. So, and I'm not saying anyone on this chat box here is lying. But I just asked the question as a matter of interest. I'm going to ask another question now and answer the question also now. Do you check the cost price from the lab? You check the cost price from the lab.
Absolutely.
Okay. What about the rest? Right. Now I'm going to ask you another question. Is the lab price always correct?
Oh, yes. We don't want to be overcharged.
Okay. And is the lab price always correct? Does it always agree with what you think it is? Not always.
Oh, my goodness.
Okay.
I think I can jump in here. What's definitely an online system in the past where people ordered email or by telephone, they could have maybe received a surface lens when they wanted a stock lens, but ordering online, you check what you order and you will get what you ordered.
Okay. Now I'm going to get to another point over here, and this, okay, obviously, well, mind you, I'll get onto that later on as I go through examples over here, and then we can sort of see basically if everything is being checked properly. Okay. I'll just go out of there again. Where do I go over there? That there, okay.
Yes.
Right. When it comes to checking your glasses, now, let's just change to the next slide here. Oops, sorry, I'm going the wrong way. Over there. Okay. Are you people familiar with SANS? This is the South African National Standards. Now, you perhaps might know it as the SABS, South African Bureau of Standards. So when you check glasses, I know what I've experienced before with certain labs. We talk about tolerances on power and access and everything like that. And then and I remember getting a comment from a lab, and they said, their lab, 0 tolerance. Now, does that sound familiar to you? Is BBGR 0 tolerance? I'm only saying BBGR because I'm presenting BBGR tonight. No, I'm not throwing you under the bus. In fact, it goes for any lab for that matter. Has any of the labs ever told you, send your work to us, there's 0 tolerance, all our jobs are 100%? Does it ever, has anyone ever mentioned that to you regarding that? I'm just asking, maybe you haven't asked the question, or maybe the lab manager has expressed, we have 0 tolerance in our lab, all our jobs are perfect. Well, if they, no. Okay, maybe you just haven't asked the right question, or maybe it hasn't come up really in the conversation. Okay, but I've had a conversation with a person who said there's 0 tolerance, and I said, man, don't come talk nonsense over here. But anyway, right. Now, there's a reason why you have a South African national standard, and that is all labs are allowed these tolerances. Sorry. Next slide. Now, I don't know if you're all familiar with these tolerances. Some may be familiar, some may not be. But just to show you what the labs are allowed. Now, when we start talking about powers, now in many cases, you will find the powers are pretty good, especially if they stock lenses and the lenses are of a good quality. But if you buy some of these out cheaper, you'll find that those powers aren't always correct. But this just goes through your tolerance over here. Now, up to and including the +4 diopter lens, plus and minus, the lens is allowed to be 0.06 diopters out. So in other words, it can either be 4.06 or 3.94. Okay? And this also applies to cylinder power. It applies to both sphere and cylinder. Over a 4 and up to including an 8, the tolerance there is 0.12 diopters. And as we go higher, you'll notice that up to a 13 plus and minus, you can also be 0.12 diopters out. Over the 13, up to a 20, your tolerance is a quarter diopter. And of course, over a 20, the lab can be 0.5 diopters. Now, these are tolerances laid out by the South African national standards. Now, I'm sure you'll find in certain cases that when you, especially with high powers, you may find that you might be slightly more than 0.12 or whatever. But anyway, that will be for you to decide whether you accept or not. but the lab is within their right to send those glasses back to you if it falls within tolerance. Now, something I must express. These are South African national standards. Certain labs have their own standards. You may find that these standards here are quite strict, if you know what I mean. But some labs might say, no, it's not 0.06, it's 0.09 or whatever. But I'm only referring to the South African national standards. If labs have their standards, you have your standards, you can pick and choose whichever standard you prefer. So in many cases, it's your choice whether you reject or whether you accept. Okay, let's take tolerances on axis. Up to including, 0.25 sil, you're allowed to be 5 degree, you're allowed a 5 degree difference in axis. In other words, if I ordered axis 180 and the lab gives me axis 5, the lab is within the right to send it. Now, up to 0.50, you're allowed 3 degrees on your axis. Over 52, over the 2, 1. Now, this is where we land up with arguments again. What vert are you using? Now, you may think I'm being a bit nitpicking over here, but it's fact. If you're the optometrist now, you are using a digital vert, where you just put the lenses in and the script comes out automatically. You don't have to work anything out. The script is spelled out. Provided you've placed it properly in the vert, it's going to spit out sphere cell axis for you. If your lab now is using a tube vert, now with tube verts and a digital vert, you may find you're going to get a slight discrepancy, especially with the axis. Now, if your lab is using a tube vert, and for example, and I've seen this happen, let's take over a 2 sil, and we're talking our powers. You're allowed 0.12 or over the 2 anyway, and over the 4. You'll find that your lab will squeeze that tolerance into there to whatever they are seeing, and also the axis. They might be 3 degrees, but they'll squeeze, because you must remember, when you're using a tube vert, it's visual. When you're using a digital vert, it's digital. And this is where you find some people very fussy when they're using a digital vert. They say, no, the vert says that. But if you're using a tube vert, you might find a slight discrepancy in your power and your axis. Now, I can tell you right now, if labs are using tube verts and the optom is using a digital, sometimes it can cause a few arguments or a few discrepancies. But I'm just making mention of this because I don't know if you've ever had an argument with your lab where you're saying this is that and the lab is saying that. It happens. Now, a lot of it depends on what vert you're using. Because if you're using the digital vert, where it just spits out the prescription for you, and now you're using a tube vert, sometimes it's not always the same. But that's probably an argument for another day, but I'm just making mention of it. Right. Tolerances of optical centration and individual lenses. Right, now we're talking about horizontal centration up to 2 diopters. You'll see your prismatic effect, your limit there is 1/4 diopter, or decentration is 1 millimeter. Now that's per lens. For example, if I want a PD of 65, okay, and the lab gives me a PD of 63, it falls within tolerance because I'm allowed a 1 millimeter decentration. But there again, it depends now on your power. You're only allowed with the tolerance 0.25 prism diopters, which is ever the greater. So I might be 1 or 2 millimeters out in the PD, but if the prismatic effect along the horizontal is greater than 0.25 prism diopters, that means it's no longer in tolerance. So which is ever the greater, if you know what I'm saying. And a lot of this is now going to depend on the power that's been prescribed. Now, as you can see over here, up to 2 diopters. 1 millimeter on 2 diopters is 0.2 prism. Now, and if you're 1 millimeter, it's going to induce 0.2 millimeters, 0.2 prism diopters. So now, if now you are 2 millimeters out in each eye, it's going to throw it out with intolerance, because now your prismatic effect there will be 0.4. So although you're only 2 millimeters out in each eye, you might be 4 millimeters out on your PD. It's going to be up to you to decide whether you accept or not. But anyway, we're just talking tolerances now. So if everything falls within tolerance, the lab is within their right to send it. Per eye. Yeah, these are per eye, okay? Per eye. Vertical centration, 0.15 in the vertical. Now, I'm going to ask a question over here, and I'm going to open the chat box, and I want to see what your answers are here. When you end up checking your prescription, do you check for vertical prism? Now, when I say vertical prism, I'm talking about unwanted vertical prism. Just say yes or no. I'm putting you on the spot now. Oh, I'm not getting any answers here. Oh, what's happening now? I get one that says yes, one that says no. Yes, no. What about the rest? What about the rest? Not many are answering these questions. Only on high powers. No. Oh, okay. Let me know who you are so I can do the work for you. Okay. Then I'll give you so much nonsense over here, you wouldn't know how to check it.
So the general answer is no.
General answer is no. Okay. Okay, no problem, no problem. Right, for multifocals, horizontal centration, you're allowed 0.25, and the same thing applies with your decentration, it's 1 millimeter per eye. Okay? And
Anthony, on your vertical prism, for most single visions, you're referring to single vision now.
Anything. Multifocal, single vision, anything. Nothing to do with Segars. I mean,
optical centers weren't.
No, well, you see, right, we're just clarifying something over here when it comes to bifocals. What Belinda's just asked now, do Segars and things make a difference to things like that?
Vertical centration.
Vertical centration. The answer is no, because your Segars are measured according to where your pupils are. And it's usually about 4 millimeters below, thereabout, give or take. So that means they are lined up equally. So if you've got a high Segite, it means that the pupils are sitting higher up. So no. So you'll check your prism at that same point, same reference points. Does it make sense?
Yes.
Okay. And vertical centration over here is 0.15 also. If you do have a question, I'll just pop into the chat box every now and then just to see what your question is. Because I know sometimes at the end of the lecture, you've actually forgotten what you asked. Should all this not be shut down by what? Should all this not be done by
the lab as their final quality control?
Absolutely. But you must know some labs take a chance. And, you know, this is a very good question to ask. And I can tell you why. You know, I don't know if I should say this. Mustn't say it.
I say it.
Okay. Labs get to know their customers. Okay, Belinda will disagree with me.
It's done on order numbers, not customers.
Okay, she's covering up here now. Okay. Well, let me tell you how things work in a lab. Generally speaking, the labs try to be as accurately as possible. Okay. And I mean, I don't think labs are going to do anything out of the ordinary. They do their best to get to do it according to your specifications. But on the odd occasion, you're going to find, and it happens no matter, I mean, even optometrists make mistakes with their scripts, you know, and Jevin, you asked, what was the last question?
It was, do you measure your vertical centration? Do you check?
No, but the question over here, Jeff, can you see the question above? It says, shouldn't this all be done by the lab? The answer is yes. But what I'm saying is sometimes you find that the technician made a slight little clipsy and he made the height a bit lower than the other. And unintentionally, you may find there's a bit of vertical prism, or you may find that the PD is slightly out. But all labs do it. And it's not done intentionally. Sometimes when they block in the lens to cut or whatever, they might decenter 2 millimeters instead of 1, or vice versa. So when your end product comes out, you may find that your PD might be out 2 millimeters, not intentionally. So now your lab manager has to now decide, do I take a chance on it or don't I? And depending on the manager, he might say, okay, right, let's take a chance on it. It shouldn't affect the patient. But there again, it's now for you to decide, do you accept or do you reject? But I don't believe any lab will do anything intentionally. But if they make a mistake where obviously it's going to make a big difference to the patient, they will redo the lens. But if it's touch and go, I mean, I'll even do the same. If I find now that I'm 1 or 2 millimeters out in the PD, I'll take a chance on it. But there again, that's up to the optometrist to accept or reject. And if they don't know their tolerances, they wouldn't quite know the difference. So this is the purpose of tolerances. And also a lot of it depends on you, the optometrist who is checking. So if you're asking the question, shouldn't this be done by the lab? Yes, but you are the double check. I mean, if I'm making glasses for you, it's up to you to make sure that I've done my job correctly. So that's basically what we are discussing over here. Okay, does that answer your question? Right. Over here. Okay. Right, now this is tolerance for, if you are now prescribing prism, this is for prescribed prism. Now you might want your prism at a certain angle. Now what we are talking about here now, I know what many optometrists do, they will give a horizontal and a vertical component, okay? So in other words, I might want 2 in and 2 up. Now if you take a resultant over there, it's going to be, if you're using a bit of maths, a bit of trigonometry, it might be about 2.2 at axis 45, if you know what I'm saying. We're talking about a resultant. Now, yeah, you can see your tolerance is in degrees. So if you want 2 prism at axis 45, and you find now that it's not quite at 45, it's either at 50 or it's at 40, it's within tolerance. Same thing, over 3 diopter prism and including the 6, you can see how your tolerance decreases slightly, where you can only be 2 prism, 2.5 in each eye. And if you're over 6, you only allowed 1 degree off. Do you understand what I'm saying by this? It's normally your resultant prism that they are talking about. Now, I know in many cases, people don't prescribe resultants. They normally give a horizontal and a vertical component. And then if the lenses are manufactured properly, then it would come out correct. And there again, it's up to you, the optometrist, to make sure that the lab is doing it correctly. But there again, we go back to our tolerances. If it all fits within the tolerance, the lab is correct. Right. Here's an example over here. You got a script now. This is your script. Plus 350 minus 125 axis 180. Plus 3 minus 2 axis 10. And this is a bifocal autoprogressive. You want an add of 250. Okay. You send this into the lab. Don't worry too much about PDs and SEGARTs. Just forget about that. We're assuming everything there is correct. Now it comes back from the lab, and you receive that script, plus 3 minus 125, 180, plus 3 minus 2 axis 10. Now you can see I'm just going back to what you ordered, which is correct. But somehow now you check the ad and you find the ad is 275, but you want a 250. Do you accept or do you reject? Now, I know I'm asking you questions over here, but now there's a reason why I deliberately use this as an example. Okay. You asked what's the question? What was the question?
Will you accept or reject?
Yeah, you receive that from the lab. Now, the question is, do you accept or do you reject because of the ad? Did someone ask a question over there?
Nothing people didn't answer.
Right, you will accept, okay. Lebo, you will reject. What will the rest do? Right, I get one accept, one reject. What about the rest? Or reject as margin of tolerance for ad, right? Accept, 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 reject,
Just
reject.
intolerance. Yes, accept, accept, reject.
Okay.
So it's 50-50.
Okay. Now, here comes the tricky part. I'm going to get back to this answer over here for you, okay? So before I give you my version, I'm not saying I'm correct, but I'm just going to add to this and you can see exactly what I'm talking about. We're talking about how you check glasses. Now, whether you're using a digital or whether you're using a tube, so I'm going to use a tube vert, probably just because I want to use a tube vert, okay? Now, many people have a tube vert. A lot of you will have a digital vert. Right, now you're familiar on how to use a vertometer, okay? So when you check in single vision, we all know you place the lens on the vert, you place the convex surface facing you. As you can see there, this has been a tube vert. You can see here by the temples are facing downwards. Now you are checking single vision lenses like any other pair of glasses. Okay, this is pretty straightforward. There's no rocket science over here. And of course, you'll check the other lens, making sure you're on the same level so that you don't get any prismatic effect or you aren't picking up any prismatic effect. All right, that's not rocket science. That's pretty straightforward. Right, now it comes to checking bifocals. Now, this is the point I wanted to make. When you check a bifocal, you'll check your bifocal the normal way. I'm talking now about the distance portion, okay, to get your distance script. When it comes to checking the bifocal, now you want to check the ad. When it comes to checking ads for bifocals, what you do is you turn the glasses around. Now you can see the temples are now facing towards you. We are now checking front vertex power for distance. We do the same, we check front vertex power for the near. And the difference between the two will give you the ad. Okay. Now, this is where the question comes. But before I get to that, let me just go back. When it comes to progressives, you all know how to check a progressive. When you check a progressive lens, there's your, can you all see my pointer here? Now, just to reiterate, when it comes to checking the ad, you've got to check that ad power in that circle. Now, obviously, you're going to have the right card for the right progressive. You divert from that circle, you're going to get a distorted image. Okay. But I'm sure you're all aware of that. And when it comes to checking progressives, same thing applies. You'll check for distance, back vertex power at the distance reference point. Okay. When it comes to checking the near, we do exactly the same. You turn the glasses around, you check front vertex power of distance, and then you check front vertex power of the ad, okay? And the difference between the two powers is going to be your ad power. Now, the key thing over here, when it comes to checking ads, especially with plus, not so serious with lenses of negative power, but more with plus, you want to check front vertex power. You don't want to check back vertex power on an ad. Now, you might ask the question, why? It's pretty simple. When you do a distance VA test, where's light coming from? Light is coming from a distant object. When you do an ad, where is your target? Your target is placed at a finite distance, roughly 40 centimeters in front. So you've got diverging light entering the ad. So you've got to check front vertex power when it comes to checking the ad. Now, the point I'm making over here, depending on the power, and I'm going to go back to the script over here that I said over here, the script. Your distance script was plus 350, and your ad, sorry, you wanted a 250 ad. So that means the near script is going to be somewhere around, okay, it's going to be plus 6. The 6 is quite a high plus. If you actually check back vertex power on a plus 6, the ad is going to come out strong. It's going to come out strong, and you're going to think the ad is incorrect. Now, that's why I deliberately put this over here. And okay, I was assuming now that you checked the ad correctly, and if it was 275, you can make that decision. So the point I'm making over here, when you checked your ad, did you check it correctly? Did you check the ad correctly? If you did not check it correctly, you would pick up a 275. If you checked it correctly, front vertex power, you would pick up a plus 250 ad. So in other words, it all depends on how you check this job. Is there a question there? Okay. Yes, we missed the part about bifocals on the.
Explain it again, so it's fine.
Okay.
Okay. So who measures it like this?
Right, now the question is, do you all check your ads the way I've just explained it? Now, I'm sure some of you do, and I'm sure many of you don't. So I'm not going to put you on the spot, but what I'm saying is if you happen to find your ads are coming out too strong and you check in back vertex power, the ads are going to be strong. So if you do front vertex power, the ads are going to be correct. And it's more with plus lenses than minus. Let's go back. So let's go one back. Right, so now we go back to this over here again. If you've checked the ad correctly and the ad is 275, then of course the ad is incorrect. And you can decide whether you accept or whether you reject. But if you checked it incorrectly and you check it correctly, you would find that that ad is going to be correct. So whether you accept or reject, if you've checked it correctly, the ad should be 250. But if you have checked it correctly and you're picking up 275, well, then that's up to you to decide whether you accept or not. So, you know, it's always easier to accept a higher ad because, you know, the patient can normally adjust his working distance. But if your distance power is overcorrected, then it's going to be blurred at distance. So as for the ad, you can always adjust your distance, but your reading distance, but you can't really adjust your distance, vision distance. Is this only for bifocals and not? No, for both. It's for both. It is for both. Bifocals and multifocals. It's the same. Can I? But Jeff, you'd normally find your ads, you know, when you check your multifocals, the ad is normally impregnated onto the marker engraving on the temporal side. Generally, those ads are correct. I can't say I've ever picked up an ad that's incorrect. And normally they're correct, you know what I'm saying? But when you check it on the vert, then it's a different, then it's you've got to check it back vertex power. Right. Any questions? You all happy with that? Is that another question? Not? Okay. Right. Let's take example 2 here. You got a script here, -4, -125, axis 180. Left eye -4, -2, axis 20. PD 65. A 1.6 single vision transitions ARC. You send it to BBGR to fit. Okay.
We make it perfectly.
Okay, they are what they call zero tolerance.
No. We just make it good.
Okay, right. But now, unfortunately, I'll click here.
Yes.
Unfortunately, this is what you get.
Oh no, then you didn't send it to BBGR.
It was one of those things. Okay, it was one of those things. You wanted minus. Let's see what I got there. Right, let's go there. You wanted -4 minus 125 180, and -4 minus 2x is 20. Okay, that's what you wanted. So somehow this is what was sent. Now you can see you wanted -4. But you got -412. Axis you wanted there was 180, you got 3. And well, I'll tell you what I'll summarize everything now for you. But as you can see, it's not quite what you ordered. Well, you see, if it was a tube word, you would squeeze -4 there. But you can't do it with the digital. You see what I'm saying? You can squeeze the axis with the 3. But you can't do it with a digital.
So this is a digital word.
So this would be a digital word,
Yes.
yeah. Okay. Right, now let's just summarize everything here. This is what you ordered. They can see this cursor there.
Yes.
This is what you ordered, -4 125, -4 minus 2x is 20. Now, this is what you received. So I've just circled the axis. You see degrees of axis. In other words, that's not with intolerance. Same thing over here. You got a 2 cell. Your axis is 3 degrees off. Now look at your powers. You're slightly strong in both. Now, if we look at a power cross, this is what the power cross should look like. -4, -525. That's your power cross. And for the left eye, is -4, -6. Okay. But now this is what you've received. You've received 412 minus 550. And over here you got 412, 625. Is my adding up here correct? Yes, it is. Now, I take it you all know how to do a power cross. If not, this is a good refresher for you. Now, that's number 1. Number 2, the axis is not quite with intolerance. I wanted PD 65 and the lab cut in PD 62. Now, if we do the calculation with the tolerances now, you see that your tolerance over here is 0.62 per eye because I am now 3 millimeters out on the PD. And it's going to be 1.5 in each eye. Now, if you remember Prentice, it's power times centration, and it's 0.62 in each eye, 0.62 out, and it's 0.62 out for the other eye. So your total prism here is 1.2 prism out. And of course, your axis is 3 degrees. Now, if you just look at, just by looking at it, you'll think, okay, I'm only 3 out in the PD, doesn't look too bad. Okay, the power is probably 012 here, 012 there. But now look at your power crosses. Your 012 over here, where I wanted a 4. I wanted 525, and now I've got 550. So I'm 025 out over there. And the same thing over here. I'm 012 out along the horizontal, and I'm 025 out along the vertical. And you do the calculation as your prismatic effect. Do you accept or do you reject? Now, I want to ask this question. Well, what would you people do? Click on you. But really, axis 180 and 3 are on the same plane. Really? Really? You take a person who's wearing a 2 sol and you turn it 3 degrees. I'm just saying, don't come and moan at me. I didn't set out these tolerances. The question is, do you accept or do you reject? If you're looking at tolerances, you are within your right to reject it. You are in your right to reject. Reject. Okay. Now, I know I'm going to get mixed feelings over here. I'm going to get mixed reactions. Some of you will reject and change to another lab. Hey, but BBR did this lab. BBGR is your lab.
I'm not going to use you again, Anthony. This is the last talk.
Right. Now, all what I'm doing is I couldn't care whether you accept or reject because the choice is yours. Now, I don't want to hear your long stories, because only 3 off. That's not the point. The point is, are you aware of what you can accept and what you can't accept? So I'm just pointing things out to you just to make you a bit more aware. If we do the maths, the cumulative effect of all intolerances would mean reject. Absolutely, yes. How to be practical, I would try and dispense and see patients' tolerance. I'm sure many of you would do it. But now I've got certain people that would accept, and I get certain people that would reject. Can you see that? So I'm just pointing a few things out. But now I'm going to change. For those of you that rejected, and there's nothing wrong with rejecting, you are within your right to reject. Now what I'm going to do is I'm going to turn the tables a bit. We now get the same script, okay? Same lenses. You order uncuts now from BBGR.
No, they order it from your lab now.
Anthony. No. Listen.
BBGR has been slandered enough.
Well, I can't say other labs here because I don't want to promote any other labs here. Right. Now, you have your own practice and you have your own technician, okay? You've got your own technician. And the reason why you have your own technician, of course, is, as far as I'm concerned, if you can have a technician on your premises, I'll say, oh, well, go ahead and do it because it can sort of improve your service. You can give a same-day service if you carry a small stock. But now in a case like this, I don't think this is, it's not a stock lens, so it has to be made 1.6. Now, your technician cuts it in, okay. Now, he cuts them in as below. Now, of course, the power you get from BBGR is 412, 125 axis 3, 412 minus 2 axis 17. Now, look at your axis over there now. It's also 3 degrees off because this is here what you wanted. And, of course, the PD you cut in there was 65. So now, as you can see, the uncuts aren't quite as bad as previously. But now, you are not within tolerance because your axis is 3 degrees off in each eye. Now comes the question now, and I want to see how quickly you answer this. Do you accept or reject? Quickly, yes or no? Let's see your responses. I'm not getting any responses over here. What's happening now? What's happening? Oh, no one's commented. Why?
I think because you're rude.
I'm not rude. I'm not rude. Do you accept or do you reject? Accept, yes. Reject. I have you know that if you reject it, your lab has cut the lenses in. Are you with me? Now the lab will not replace that for you no charge because you have cut the lenses in. Can you all hear me? Can you all hear? Everyone can hear? Okay, you can all hear. Okay, good. Okay. Now, all I'm saying over here, it's a case of now, obviously, it's up to you to decide whether you accept or whether you reject. Now, all I'm saying is there are tolerances that are allowed, and it's up to you to decide. Now, of course, in many occasions, you'll find that, okay, you'll take a chance on it. And if the patient rejects it, at least you know why. But if you don't check your jobs and you just give it to the patient and the patient comes back, then it's going to make it a bit more difficult for you to decide now what's the problem. So it's always good just to check your jobs, see what you're sending out, and make that decision. But if you don't check your jobs and you don't know your tolerances, then, of course, it just makes it a bit more difficult for you to decide. I mean, if you're not checking your jobs, you'll give everything out to the patient. And you'll probably find 9 times out of 10, the patient will accept it. But on the other occasion, you might find that the patient might reject it. So I'm just bringing it to your attention just to make you aware of all these tolerances. Right. Let's go minimum blank size. I'm sure you're familiar with minimum blank sizes as to how big must the lens size be for you to get the right PD. Now, consider a frame with the following parameters now. The frame is a 5614. Now, this is a datum measurement, 56 along datum, 14 millimeter bridge size along datum. So that means the frame PD is 70, okay? Effective diameter, that's your longest diameter, is 58 millimeters. That's your longest diameter. Now, you get a patient, the script here is -2, and he has a PD of 61. Now, what you would often want to find out, will a normal stock lens be big enough to get the PD? So what you have to do now is calculate the blank size. Now, this is more important for you if you have your own lab. You know what I'm saying? So you'd know that to get the right PD, will the stock lens be big enough to get the right PD? Okay. And well, for that prescription. Now, from the equation I've shown you how to get your blank size, you are going to use an equation over here. Minimum blank size is going to be the frame PD minus patient's PD plus effective diameter plus 2. Now, you may be asking, where does the plus 2 come from? Where the plus 2 comes from is, if I left the plus 2 out, that would basically give me the diameter of the frame without a bevel. So we allow that extra 2 millimeters so that you can cut a bevel so it fits into the frame. So that's where the 2 millimeters, that's where the plus 2 comes in. So now to calculate over here, for this prescription, it will be 56 plus 14, which is 70, minus 61, which is the patient's PD, plus your effective diameter plus 2. So you would need a 69 millimeter blank here. Now, your normal stock lenses in minus over here is going to be 70s. So if it's ordinary single vision or single vision AR coating or whatever, if they have it in stock, a normal stock lens would be quite surface over here to get that PD. All happy with that? So that's pretty straightforward. So just to recap on how we measure blank sizes.
This is very important actually for...
Reject your own redo, okay? Javin, I don't believe you. Okay.
This is very important for plus lenses that only come in small stock.
What generally, yeah. Right, you're going to see here now. Right, just to give you an example over here, I've taken this shape. Datum size was 56. Bridge size was 14. Effective diameter here was 58. And distance between lenses 14. So we needed a 69 millimeter lens. So from a frame PD of 70, we've got to push this lens, we've got to move the optical center 4.5 millimeters in each eye. But you can see over here on the edges, I have 5.5 millimeters to play with. So I'm going to push it in 4.5, and that extra millimeter over here will allow me to put a bevel on. So just to explain to you more or less how minimum blank size works. Okay, right. Now we're going to do some homework over here. We see if you people are checking your prices, okay. Now we have a script over here. Right and left plus 2 diopters, 1.56 photochromic plastic, PD 61. Okay. Now, this is going into... well, we'll get to the frame later. Okay, we'll get to the frame later. Now, I know you people check your lenses and you check your prices. Now, you check on the prices. Okay, don't be too concerned about the price. I don't know what BBGR charge, but it's the stock lens, AR coating. And according to your price list, it's 70 Rand. Now, this is an El Cheapo. Eh? It's not a transition. It's an El Cheapo photochromic. 70 bucks a lens. In fact, I can get them for 70 bucks, okay. Then 40 Rand for the fit. What do you charge for fitting? $40 per lens. Would you know offhand? Okay, let's just assume 40 Rand, okay, for the time being. I don't think I'm going to be far out. So that's going to be 110 Rand a lens. So in total, when you get your invoice, you would expect the script, the invoice to be 220. Are you happy with that? Does it make pretty good sense to you?
Math.
What's arithmetic? Okay. Right. Would anyone disagree with me over here? Now, we're not using the transition or the top of the range photochromic. We are using one of our cheapos, $70 a lens. If you're not aware of these $70 lenses, phone your local wholesaler and they will inform you as to the prices. Okay. Right. You get your job, and now all of a sudden you see now, wow, they're charging me 410 Rand a lens plus 40 Rand, and now they're charging you $900. Is this correct? Is this correct?
Well, not if the price list was the first one.
I'm asking.
No, but you've got the price list. Or is it an imaginary price?
No, this is your price list, off the price list.
Well, then it's incorrect.
It's incorrect. So what they've done over here, they've charged you surface price, okay? They've charged you surface price. Now, we are using the same example over here with this frame size, okay? Now, if you do the maths, where are we? Okay. This is a stock lens. Now, a stock lens, first of all, if you check your glasses correctly, you would have found that you would have been about 3 or 4 millimeters out on your PD. Okay. Now, what the lab has done, they know that you're one of these fussy blighters where you insist on the correct PD. So what they've done over here is they've charged you surface price to get the correct PD. Are you with me? So in other words, for plus lenses, your blank size is 65 millimeters. If it was minus lenses, your blank sizes are 70 millimeters. So if you wanted a +2 and you wanted a PD of 61, for that script into that frame, they would have needed a larger blank. Now, if you are very fussy about your PDs, the lab would have charged you surface price, and that is where the discrepancy comes. So the point over here, I'll get to your questions now. Now, the point over here that I'm making, if you're going to make the assumption that they're going to use a stock lens, I would suggest that you inform them, give me best PD with a stock lens. If you're one of these people who always reject lenses for PD, they are going to charge you surface price so they can get the correct PD. Do you understand the point I'm making? And this often happens. I can tell you right now, it often happens. They charge you surface price because of the PD. For 65, it's only, plus lenses are only 65 millimeter, minus is 70 mil. 70 mil would have been better. Right, let's see your questions over here. I don't see any questions here. Right, they need to phone you.
Not surface, yes. So it's correct.
They need to phone you.
Yes, they need to phone you if you've ordered stock and they have to change it. Correct.
Yes, right. Now I'm going to go back to my original statement where the reason why they've used surface lenses, because you're perhaps one of these fussy patients that want everything 100% correct. If you were one of these customers that's very lenient, they would use a stock. Otherwise, they would phone you. So I'm going worst case scenario, basically. What are you saying? Were you going to say anything? Okay. Now, I know many people would argue with me or whatever, but I'm just pointing out, I've seen cases there where they charge surface because they talk about the PD. Right. Now, I'm just giving you basically a profile of lenses over here minus. As you can see, larger the frame size, the thicker the edges, smaller the frame size, thinner the edges. This is pretty basics. There's not much to really discuss over here. Same thing applies here in cases of plus. If your frames are small, order blank sizes, and you'll end up getting a thinner lens. So as you can see, if I'm using a large frame, I'm going to have a thick center. If I use a small frame, order the correct blank size, and you'll have a thinner lens. Right, that's pretty straightforward. I don't know if many people order minimum blank size when it comes to plus, but there again, I'm just making you aware, and I'm sure you all are aware that, especially in plus you can order a smaller blank, but with minus, you've got to order a smaller frame to get thin edges. Right. Now, just here's a quick I'm going back to blank size again. This is a little bit of a tester for you. +4, -4, axis 180, PD 60. These are my frame parameters. A 5220, A measurement 52, that's the long datum. B measurement 34, that's your vertical measurement. Distance between lenses 20. Effective diameter 54. Calculate minimum blank size. So if we follow the correct equation, in fact, you can double check me if I'm wrong here. We need a 68 millimeter blank size. Are you all happy with that? Does that make perfect sense? If you disagree with me, I think you must do the arithmetic again. But I think this is correct. Okay. Right, let's give you another example over here. Right, now we've got a different power, +6 -6 axis 90. Same parameters. If we did the same calculation, it's just a different script slightly. Blank size works out to 68. Are you all happy with that? Huh? Anyone disagree with me? Right, I'll disagree with you. That's not correct. Now you're going to ask me why. Now, some of those who interpret the prescription can see why. You need a correct blank size of 56. Now, you may be asking why. Draw your power cross. +6 is vertical. You've got plan along the horizontal. PD doesn't mean a thing. Have I gone too fast over here? +6 -6 axis 90. I can just take the blank size over here and add 2 millimeters. Effective diameter and add 2 millimeters. Because the power along the horizontal is planar.
That's only in a planar and horizontal you can do that.
Well, yeah, that's why you've got to interpret your script. Just going back here very quickly, if you notice the first example I gave you, axis was 180. I've got +4 along the horizontal. Change your axis to 90. In that case over there, your power along the horizontal is planar. So now you're going to use an extra thick blank. The lenses are going to be thicker. And point here is interpret your prescription. And all you do that is with a power cross. Right, are you all happy? I see one question here. Let's just see it quickly. No power in horizontal? Absolutely. Right. Right, now you got a bit of homework here too. Let's see how good you are. Yeah, I'm nearly finished. I'm going to go through this quite quickly. Okay. Consider the following RX -2 -4 axis 90. What? CR39 ARC. These are your frame parameters. 55, A measurement, B measurement, which is the vertical 34, ED 60. Distance between lenses is 20 because it's a 55-20 frame. Center thickness of the lens is 2 millimeters. Okay. Now, you must calculate the minimum blank size here. First of all, for a PD of 75, 70, 66, and 60. Okay, I don't expect you to do this because this is homework and that might take long, but...
I'll email the slide for people to do.
Okay. And also here, calculate the edge thickness for each PD. Are you all happy with this? Don't worry too much about this. I've done the calculation for you. Okay.
I'll include this in the CPD questions.
Yes, I have. No, I haven't. Right. Now, this is your frame. Now, there's a reason why I'm doing this, because it's just to make you people more aware. I'm sure a lot of you are, but sometimes you don't think at the time when you're choosing frames. Now, your frame PD is 55 plus 20, which is 75. So that's your frame PD from geometric center to geometric center, 75. Now, you've got to calculate minimum blank size for PD 75. Effective diameter over here was 60 millimeters. So all I need over here, plus my PD is 75, there's no decentration. So I just need the effective diameter plus 2. Because if you take in the equation, frame PD minus patient's PD, 75 minus 75, which is 0, plus 60 plus 2, so you need a 62 millimeter blank. As we decrease the PD, your blank size is going to increase in order for the decentration. So that makes pretty good sense. But now, as you can see, as your blank size increases, your edge thicknesses are going to get thicker. Now, let's just see over here. We want to calculate the edge thickness. Now, over here in a case like that, minus 2 minus 4 x is 90. Draw your power across. The question is, where will your thickest edges be? Along the horizontal. X is 90, so in this case, I've got minus 6 diopters along the horizontal. That's going to be thicker than your 2. Now, the equation we use over here, okay, I don't expect you to remember these equations because I know you people work off tables, but I thought I'd just include it. S is your sag. Y here is half your diameter, okay? N is the refractive index of the lens. Now, to calculate the S thickness, it's going to be the center thickness, which is T0, minus S, which is your sag. Okay. Don't worry too much about the maths. I'm just showing you this very quickly. Right. Now, all I've done is I've just calculated the thicknesses for 75 PD and the 60. Calculation is going to show that your S thickness for 75 millimeters is geometric center. So edge thicknesses are going to be the same on either side, and it works out to 4.53. That's your sag. So now we've got to add on the center thickness, which is 2, and you'll end up with 6.53 millimeters on the edge.
No one's going to do this.
No, they don't have to do that. No, they don't have to do that. I'm just showing you something over here. Now you take the same frame and the PD is now 60. I'm just doing the calculation just for interest's sake. But now if you look at how the edge thickness changes, now, why now? Why now, if there's no decentration, Y happens to be 27.5? But now because the PD is now 60, I've got 7.5 millimeters that I have to decenter that lens in. Can you see that? So Y here in this case becomes 35, no longer 27. But don't worry too much, but all I want to show you now your edge thickness now is going to be 9.35. That's what I'm trying to show you. So in other words, the smaller the PD, the thicker the edge. I just put these calculations in here just for some of you diligent students who really want to know how to do it. But point I'm making, large frames, small PDs, thicker edges. Now you can see over here, you got a 3 millimeter difference in thickness. Now you can use high index lenses, but it's all relative. It's all relative. So just be a bit careful. And I've seen it so many times. People choose a large frame, but then they got a small PD and they wonder why the edges are so thick. It's because of this. If you didn't know it, now you do. Okay. Any questions? You're all happy with that? But I'm sure most of you knew this anyway. They all knew this. So I'm just, right, now they all know this. Now just to show you over here, no decentration equals thickness. Greater the decentration, you can see how your edges become thicker. But this is pretty, it's not rocket science, it's straightforward. So if a lab phones you up and says to you, why you got such a small PD, the lenses are going to look terrible, now you know why. Okay. We'll have time for this one. Okay, just really quickly, I have I'll be very quick over here. You've got a script over here, minus 375, 175, axis 60, PD 65. Now you can look at the frame now. You can see over here that it's a wrap frame. And it's a minus 375. Now, generally, what people do, they just fit a normal pair of lenses into the frame and they think they're good, which maybe they are. But now, Your patient comes back complaining. There's eye strain. He feels dizzy. Vision's not comfortable. Why? Can anyone tell me why? Maybe you've done a bum test. Maybe you've done a bum test. So you retest him, you find exactly the same. Then you think this patient is a PRA. You know what a PRA is? Use your imagination. Right. Now, if you think carefully, right, I've got two questions over here. Prismatic effect. No. No, not prismatic effect. Right, think about this. No power. Sorry, did I miss something over here?
Distortion.
Right. Yes, distortion. Absolutely distortion. Now, can you be more? Specific? Base curve? Not really. It all depends on what base curve they use. So it could be base curve, but it could be base curve. Yes, it could. But let's go one step further. That frame. Now, you've got it can go up to a 25-degree wrap angle. Now, you take a lens and you tilt it 25 degrees. You're going to alter the vergence leaving that lens. Now, generally, if you only make this lens in best form, this is normally the equation we use. So for that power, you would need a 4 diopter front surface power. But this is a wrap frame. So generally what you do is you would put an 8 base in there so that you don't distort the frame. If you try to fit a 4 base lens in here, you're going to probably straighten that frame out and it loses its wrap. So straight away you can see if you're using an 8 base lens, it's not made in best form, so you're going to pick up distortions. But now we go one step further. Because of that wrap tilt, 25 degrees, the effective vergence leaving the lens, now calculation will show is 412 minus 275 axis 70. That's leaving the back surface. You wanted 375, 175. Now that's gone up quarter diopter. Your cylinder's gone up a diopter, and your axis has changed by 10 degrees. No wonder this person is feeling dizzy. Now, some people are more sensitive than others. I know people who have done it with the same script, and patients tend to get used to it. But now you might get the odd patient that's going to complain. And at the same time, you're inducing a small amount of prism base out.
The prism was correct.
Well, you're looking at a half a prism. So, yes, sort of correct. That's why I didn't say not good. Oh, wait, prism. Oh, sorry, I said no. Sorry, I thought you meant vertical prism. Sorry, I'll correct myself over there. Prism up to a point, yes. But if you're looking at half a prism diopter on that power, there you're looking at, it's less than a millimeter. You know what I'm saying? But, sorry, prism is, it could be, but it won't be the main concern. It's your vergence over there. So what do we have to do? We can give a compensated power. Now, by altering the compensated power, we'll still do it on an 8 base, or alternatively, we can give an aspheric lens. Now, I'm sure you've heard of these wrap lenses that some of these labs do for you, but they're quite expensive if you go to aspheric. But okay, I'm not even going to look at the cost. I'm just talking about something that's functional. What the lab would do, if there again, I think the lab should also consult with you, because now when manufactured, the tilted power here that needs to be fitted into this frame is going to have to be a minus 325, 125 axis 44 with a half a prism base in. This is now going to be your compensated power.
We call it wearer power.
Position of wearer power.
Wearer power.
Okay, terminology, same thing, yeah. So your lab should be able to do that calculation for you. So I don't know if all the labs do it, or do they confirm with the patient, this is what we suggest, or whatever. You do it. Okay. Now, in certain cases, maybe not everybody uses BBGR, but some don't. Eh?
But then if this arrives at the practice, they must know that the wearer power, the vert's going to give a wearer power.
Right, and if you all heard this, What the lab must do is send you a copy of the script.
Yes.
And now, if you're not aware of this and you get this script, you're going to think, what's the lab doing? Did they make a mistake or what? So I'm just making you aware of tilted power. So when fitted into the frame, the tilted power will give as close as possible to what you're looking for. So just be aware with these tilts. And of course, higher the power, the worse it is. So I'm just bringing this to your attention. So now if your lab sends you a job and you get that script, you're within your right to reject it because it does not fall within tolerance. I'm only kidding. No, but if the lab sent you a printout, but they should inform you before they even do it. And on that happy note, I went a bit over time, but sorry, but...
Are there any questions?
Are there any other questions?